Record. Okay. So everybody can see my screen, yeah?
Yes, sir.
Okay. Okay, good afternoon everybody and Assalamualaikum warahmatullahi wabarakatuh. And then we continue, maybe we review a bit about yesterday discussions. Actually, yesterday discussion is about estimating, yeah, estimating mean and variance, yeah, estimating mean and variance from one sample, yeah, one sample. Actually, one sample? Because it's derived from one populations, yeah. This one population, and then we take a sample many times. Maybe I worry it's makes confusion. Yeah, make this explanation become confused. Actually, the meaning of one here is coming from one populations, and the sample, that's because we are doing sampling to the from populations, and then we estimate the mean and the variance. Estimate the mean and variance of population from the sample. Okay, there are many conditions. For example, if the variance of population is known, yeah, is known, and then if the variant is not known, and then we will have a different formula, yeah, for estimating the confidential interval. Yeah. What happen if this is unknown? And many things, yeah, we already discussed yesterday. And today we move forward to the two sample. Yeah, two sample means that this two sample derived from two populations. Two populations. And what kind of estimation that we want to do? The difference between two means, yeah, populations, yeah, the difference of two means, yeah. And for example, given two populations, so we will have double means. This is mean population 1 and this is mean population 2, as well as this is a standard deviation, variance from population 1, and this is variance from population 2. And purpose of this is to estimate the differences between mean 1 and mean 2. That's why here I put delta. Delta X bar means that this is differences between sample from population 1 and sample from population 2. X1, X bar 1 and X bar 2. Particularly, how to determine the confidential interval. Okay, until this point, I hope it is clear. And given by this condition, we can consider or we can classify into 4 conditions. Yeah, we can break down into 4 conditions. First condition, we want to determine the CI, yeah, CI of delta X if the variance population is known, yeah, variant population 1 and variant population 2 is known. And the second condition, simply the variance, both variant is unknown, but the variant is equal, yeah, is equal here. And the third conditions, the variance unknown and the variant not equal, yeah, not equal. And then for conditions is there is a dependency between population 1 and population 2. There is a dependency. It means that if the random variable from population 1 occur, it is a certain percent that random variable from population 2 also occur. So there is a dependency. And then the purpose is how to determine the confidential interval. Actually, for the first condition is differences, yeah, between min 1 and min 2. So it is, we can easily formalize as min 1 minus min 2 greater than some alpha, and this is less than beta. Okay. Also for the second condition, also we still find the differences. So this one alpha and beta. Yeah. Let's say this is for the second, the first condition, and this is for the second condition. Yeah. This is alpha 3. It means that confidential interval between mu1 and mu2, lambda 3 and beta 3. And also here is confidential interval for mu1 minus mu, yeah, still, yeah, this is b4, something like that. Until this point, is there any questions? Is there any question? Is that clear? Okay. If no question, I have a question for some of you. Maybe Mahesa, are you there, Mahesa? Mahesa? Mahesa, are you there, Mahesa? Okay, Edro Sihombing, are you there?
Yes, sir.
Okay. What do you think the alpha 1 and alpha 2, it is similar or not similar? I mean, it is equal or not?
Alpha 1 and alpha 2, sir?
Yeah.
I think a bit different, sir.
Different.
Yeah.
Different, yeah. Okay. Why different, Pedro? You can answer by any reason.
Kalau reasonnya susah, sir. Why different, ya?
Why different?
I'm not really sure, sir.
Not really?
What difference, yeah.
You didn't get? Eddie Hernando, do you agree with the answer of Pedro?
Hello, sir.
Hello.
Sir, I'm really sorry. I just got in from the class. I just got into the Zoom meeting.
Okay. Yeah. The question is, What do you think? Lambda 1, lambda 2, lambda 3, lambda 4. The value will be equal or not? If we have same confidential interval, for example, 95%. The confidential interval is 95%. What happened for the lambda 1, lambda 2, lambda 3, and lambda 4? It is equal or not? Maybe using your instinct.
Hello, sir.
Hello.
I'm sorry, sir. Can I know what lambda is? I'm sorry.
Lambda is threshold. Yeah. Do you remember this one? No. It is not good here. Do you remember this one? This is lambda and this is beta. Did you join yesterday course?
Oh yeah, sir.
Okay.
I think. Oh, so lambda is also alpha, is it different?
Alpha. Where is alpha? Did I say alpha?
Tadi
For
tadi
yesterday?
apa, sir?
Oh, tadi saya ngomongnya alpha ya?
Yes, sir.
Aduh, sorry. Udah ngantuk kali saya. Oke, I mean di alpha ya, di alpha ya. Di lambda, sorry. Di lambda ya. The lambda 1, lambda 2, lambda 3, and lambda 4, do you think is that there are equal?
I think if we get from like yesterday's example, I think they're pretty close, but they're not the same.
Okay, close but not same. So in simple words, it is equal or not?
No, sir.
No. Okay. And then if you answer no, why?
Well, I think just like I said, like for the example, I think from if it's like similar to yesterday's like
Yes.
example,
Yes.
like they're close to each other, but they're not exactly the same, right, sir?
Yeah.
But they're
Okay.
yeah.
Okay. Yeah. In simple words, it's not equal, right? So why it is not equal?
Sorry, sir.
Yes.
Maybe
Yeah.
you didn't-
Wait moment, Mahesa. Maybe next is yours. Do you have any reason, RRD? No? Yes? Hello, RD? Is he experience internet difficulty, maybe? Or me?
Hello, sir. Oh,
Hello?
yeah.
Do you have any problem with my connection?
No, sir. I think
No.
yes.
Okay. So, do you have any reason why the lambda considered to be not equal?
I think is it because I think from like yesterday's question, the formula for the alpha or lambda is you subtract the average, like the x bar with the number with the alpha, but for the beta you add the number that you get to the beta. Is it like that, sir?
Yeah. That's difference between alpha and beta. Okay. Yeah, that's correct. My question is why the lambda 1 and lambda 2 are different? No clue.
I think I still understand, sir.
Still exploring. Okay.
Yes.
Okay. Okay. Mahesa, are you there, Mahesa?
Yes, sir. Sir,
Yeah.
I actually have a question, sir. That I
You
still
got-
don't understand.
You got the question?
I think I have a question because I
You have
still
a question? Yeah, what
why
question?
why we have to make 4 different conditions, sir. I think I still confused in that, sir.
Okay, why we should break down into 4 different conditions? Is that your question?
Yes, sir.
Yes. Okay. Yeah. Actually, in many applications, can be how to say, can be fall into many possibility. I mean, yeah. For example, we want to know the differences between allow me to get the one example. Okay, at least you have, for example, you have two type of charging. Yeah, let's say first is Samsung charging, Samsung charger, and then another is maybe robot. Do you know the trademark robot? Yeah, the charger Samsung, maybe in average, yeah, they have populations, the average of charging become full, yeah, become full, maybe the average is let's say 30 minutes. And for the mark yeah, robot, the mean is let's say ms, this is mr, is 35 minutes. And then with the standard deviation or variant of Samsung, it is maybe 1 minute. For the standard deviation Samsung robot become 5 minutes. 5 minutes, yeah. And then you buy, or you buy one of them, or one yeah, one each of them, yeah. So you buy one Samsung charging Samsung and one charging robot, yeah. And then actually you want to know the differences between the how long the two charger will be how to say charge our smartphone. That this is the parameter that we want to know. This is delta, yeah, delta actually x1 x2, or let's say xs and xr, yeah, bar, this is bar. That's the parameter that we want to know. So in certain conditions, maybe if you are carefully read the spec of product, maybe yes, the product specs, you found that the standard deviations is is known, given, yeah, given, yeah. Also for the robot product, after you search in the internet, maybe opening their website, you got these informations, okay, these informations, and that's good. It's mean that you no need to estimate the variance, and yeah, the variance of the charging device, either Samsung or the robot. That's good. So this follow first conditions. So the second conditions, the second condition you didn't get this information. You didn't get the informations, but in many review, maybe you got from website review, the product review, something like that. It is not a no, official, for example, yeah, not official from Samsung or Robot, but you got from review product, yeah, maybe, yeah, they conclude by their experiment that that the variance of Samsung, yeah, variant of Samsung is equal to the variance of Robot, yeah, it is equal. So it is also this condition follow the second condition, something like that. Mahesa, until this point, is that clear?
Yes, sir. And if we don't know the what's called the variance, should we use the what is called the sample standard deviation, sir? Like in the T distribution, is it?
Oh, okay. That question is should be later. I mean, we will discuss. Okay. Yeah. Good question, but I will discuss later. It's talking about the standard deviation. Talking about the type of distribution, right?
Yes, sir.
Yeah. We're gonna talk later. Okay.
Yes, sir.
So the motivation of several conditions is that clear? I mean, acceptable.
Yes, it's clear, sir.
Okay. For the third and fourth condition, so you can imagine by yourself.
Yeah.
Yes. Okay.
Thank you, sir.
Yeah. Okay, no problem. Okay. So yeah, maybe I'm asking to Mahesa. The lambda 1, lambda 2, lambda 3, lambda 4 for equal confidential interval will be not equal. Yeah, that's the answer. That's correct answer. The RT say and others say that's correct. Lambda 1, lambda 2, lambda 3, lambda 4 will be different answer, different value. Even we have same confidential interval. And that's why, Mahesa.
Is it because it depends on the variance, or
Depend on the variant.
the condition of the condition of the variance itself, sir, or?
Yeah, of course, that's because of a condition of the variance. But and then what? Actually, your question just before that. The reason is
the T distribution, or the type of the distribution itself.
Yeah, the distribution of delta X will change. Okay. So in this case, the distribution of delta X, the delta X bar is normal, and the distribution of this one and this one will be T distributions. Yeah, delta X will be followed T distribution. And also for this one, also follow T distribution. Yeah. So in these four conditions, only one condition that that delta X bar follow normal distribution. Others condition, the delta X bar follow T distribution. Okay, is that clear until this point?
Yes, sir.
Sir, I have questions, sir.
Yeah, please.
So can we use the Z formula like in the previous 2 weeks ago for
Yeah.
solving this T distribution and also the normal distribution?
Yeah, of course, you can use the Z formula, but you should how to say, carefully define the Z formula.
So it's basically the same like 2 weeks ago, right? Like we
Yes.
find the Z and then we use the Z distribution and then we get the alpha and the beta.
Yes, yes,
Okay, sir.
yes, yeah, yeah. It's almost similar with even with the 2 weeks or last week or 2 weeks before, yeah. When we talking about two different sample, but in this week we only add up with the definition of confidential interval. Actually, last 2 week we don't talk about the confidential interval, right? And in this week we combine, yeah, the basic knowledge of last week with the confidential interval. It's mean that when we're talking about the position of, let's say, delta x bar, we should also determine how accurate, how accurate that our estimations based on the confidential interval, something like that. Okay, until this point is clear? Or any question? The next is we want to formalize, we want to formulate the alpha 1, sorry, I make a wrong mention. Lambda 1, and beta 1, and lambda 2 and beta 2, lambda 3, beta 3, and lambda 4, beta 4. The next discussion. Okay, until this point, is it clear? No.
I think clear.
Yeah. Okay. 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 Actually, let's move forward to the first conditions. And we want to determine the lambda 1, mu 1 minus mu 2. Actually, yeah. Sorry. This one. And this is beta 1. Okay. Yeah. Actually, the lambda itself is consists of delta x bar, yeah, minus this is random variable from normal distributions, and multiply by the standard deviation of delta x bar, yeah. Yeah, standard deviation of delta x bar. Yeah, actually, this point we can got that's the point that we want to know, and then still something like this, and then this z is a random variable, yeah. Wait a moment. This is random variable, and this is the random variable from the normal distribution. how to compute this one is really depend on the confidential interval. If the confidential interval, yeah, 95, it is will be 1.96, and if the confidential interval 90% is should be 2.575. Actually, finding this point is by looking at the normal tabel, yeah, normal tabel, yeah. How about this one? This one is we actually we remember that this is consists of two standard deviations, so it should be the standard deviation of delta x. Actually, the standard deviation of population 1 divided by n. This is not square 2, so yeah, it's not square. Okay, plus 1, this is and 2, and this is so the standard deviation of x bar something like this, something like this, and 1 plus and 2. Okay, so with similar method, beta 1 equal to x minus plus, yeah, plus delta x, yeah. Yeah, actually the value is same for the z and for the standard deviation of delta x bar. Okay, any question for defining the formula?
Sir, for the Z, it's follow the normal distribution, right? For this condition.
Yes,
Oh, okay.
because why is follow normal distribution? Because the varian is known, right? Variannya diketahui sehingga nilai ini konstan kan? Nilai variansnya ini konstan karena konstan yang mempengaruhi hanya satu, karena hanya satu yang random, maka distribusi dari delta X bar-nya ini adalah normal distributions. Gitu. So, is there any questions?
Sir, but
Yes.
what if, so in the previous 2 weeks, you said that if the sample, the number of sample is less than 30, then we use T distribution, right? So is it the same for this question? I mean, like for this problem?
Okay, a good question. You mean that, for example, the N1 I mean equal to N2 and this is less than 30, is that right?
Yes, sir.
Yeah, is that, yeah. In this case, wait a moment. Yeah, in this case, Yeah, it is normal. Even that the number of n is less than 30. But here is that you should know the variance is already known. The variance of the population is known. And mention that population is normal. Population is normal. So the rule is like this. Jika populasinya normal, populasi normal. Kemudian diketahui standar atau variansnya atau standar deviasinya, ya, ada standar deviasi 1, standar deviasi 2, maka kita menghitung variabel ininya sebagai normal. Walaupun apa namanya? Ini sampelnya itu kurang dari 30. Seperti itu. Tapi catatan ya, ininya harus diketahui. Ininya harus diketahui. Kenapa? Why we should like that? Because once we know the populations, yeah, the variance of the populations, the perilaku apa ya, behavior of delta x, perilaku random variabel delta x itu hanya dipengaruhi oleh satu apa namanya ya. Jadi gini, delta x itu kan sebenarnya aproksimasi dari delta x itu kan sebenarnya x1 bar dikurangi x2 bar. Oke. Nah, delta x ini disebut random variable. Kenapa? Karena dia x1 dan x2 ini random variable. Maka operasi ya, segala operasi random variable menghasilkan random variable, ya. Nah, operasi pengurangan itu jenis distribusinya itu tidak akan merubah, ya. Jadi kalau misalkan x1 bar ini normal, kalau x2 bar juga normal, maka selisihnya juga terdistribusi normal. Itu semacam apa ya namanya? It's kind of theorem. Semacam teori. Kalau tidak percaya, dibuktikan, bisa dibuktikan ya dengan melakukan eksperimen. Misalkan kita mengenerate sebuah random variable dengan ya, normal random variable, katakanlah x1, kemudian juga mengenerate random variable x2. Kemudian di sini x1 min x2. Nah, x2, jika ini distribusinya normal, maka ini normal juga. Yang selisihnya ya, selisihnya itu juga normal juga. Normal. Dengan catatan ini independen ya, independen. Antara populasi 1 dan populasi 2 itu independen, tidak ada kaitannya. Okay, is that clear? Or we should make an experiment. I mean, yeah, to prove that this how to say, this is without absolute. I mean, this gap, the distribution of the differences, it's normal. What do you think? I mean, we should make experiment or not, or you can conduct by yourself. Which do you prefer?
I think we can do the experiment, sir, so that we can understand better about this.
Oh, so we need to make an experiment.
Yes.
Yes.
What, like experiment right now, right?
Yeah.
Yeah. Okay.
No problem.
Sir,
Yes.
eksperimennya ngapain sih? Maksudnya what we do? If it's no.
Eksperimennya kita mengenerate, jadi kita kan istilahnya teorinya adalah kalau X1 itu terdistribusi normal, kemudian X2 itu terdistribusi normal, selisihnya random variable kan? Sepakat ya? Sepakat nggak?
Yes, sir.
Yes.
Yes enggak. Okay, I'm considering using Excel or MATLAB ya. Wait a moment. I considering using MATLAB. Maybe. Okay, wait. Maybe Excel better ya. And maybe I want to show the Excel ya, maybe ya. Excel. So okay, you can see that my Excel, and then I want to this one. Actually, first is how to generate. First, we want to generate random variable that follows normal distribution ya, normal distributions. Okay. Generate normal random variable for the, let's say this is x1, this is x2, yeah, let's say x2, and for the x1 mu become equal to, let's say 5, and then for the second mu equal to 7, and standard deviation STD standard deviations equal to 1, and this is standard deviations equal to 1 is okay, 1 okay ya. So no problem. Standard deviation is 1 is okay. So we want to generate the random variable. So the syntax is according to, yeah, you can check by internet, yeah. Norman inverse, this one random, something like this. The probability, the mean it should be 5 and standard deviation it should be 1, something like this. Okay. You generate like this, and then using same method you can, this is we change, right? 7 became 7 and standard deviation is 1. Okay, so we generate, okay, we generate to show the insert. No problem. Okay, so we generate at least maybe yeah, it's around maybe around 230, yeah, 130, and then we want to check. So and then we want to check this is x1 minus x2. Okay, this one minus, so we put like this, minus 1. Okay, we then, okay, and then we want to show, we want to first we want to check whether we want to plot the x1 become histogram. So we want to insert. Can you still my Excel? Can you still see my Excel?
Yes, sir.
Yes, sir.
Yes. Okay. Insert the histogram. Where is the histogram? Yeah. All chart histogram. So you can see here, or we can format this number of pin 11 mungkin jadi 15. Why we change become 15 biar lebih bagus saja tampilannya. Atau become 20 bisa nggak? Lebih jelek. Hmm, 19 ya. Okay. And then using same method also we want to plot this one into histogram. Insert this one, histogram, and okay. Okay. No, this one. Okay, and this one. Insert also histogram. Okay. So annotations. So this is x1. So you can see why I plot histogram actually is to show the how the pattern of the graph, yeah, the pattern of the graph, and it is no doubt that x1 is a normal distribution. So can you see, yeah, x1 is normal distributions. Okay, everybody agree or not?
Yes, sir.
Yes, sir.
Okay, okay.
Yes, sir.
The x2 here, x2 is normal, right? As we generate from this one, and this is the x2, and this is the one. And you can see the the differences, yeah, between x1 and x2 also follow normal distributions. Okay, so we already proved that the selisih, ya, sorry, allow me to explain in bahasa. Jadi selisih antara random variabel, ya, di mana tiap-tiap random variabelnya ini terdistribusi normal, maka selisihnya juga terdistribusi normal. Ya, ini kita sudah melakukan eksperimen. Okay, is that clear or any questions? Any question? No?
I
Hello?
think no, say.
Are you still thinking? No problem.
Lanjutin aja dulu, sir. Nanti kalau saya bingung, saya tanya.
Okay. Okay. So we back to the PowerPoint, yeah. Yeah. So in this PowerPoint, at least from this one, we agree with this theorem, and since the delta x bar is normal, so what is the mean of the mean is x1 minus x2. Actually, we can obtain this value from observations, and then we want to normalize, yeah, actually this mu1 minus mu2. This is the standard deviation of delta x bar, yeah. Yeah, standard deviation, and you can see here minus x2 and this is followed by sigma 1 pangkat 2 ini dibagi n1, sigma 2 pangkat 2 bagi n2, something like that. Okay. Okay, that's formulation from first conditions. So we no need open MATLAB. And then So I have an exercise. Um, um, following these conditions, yeah. Please conduct the exercise by yourself, and then we check together. Okay, anyone can see, yeah, the exercise, yeah. Okay, please conduct maybe in 15 minutes, yeah, in 15 minutes. The question is find 96 confidential interval. So in this case, it will change the value of z. Yeah, it will change the value of z. It means that you have to determine the value of z based on the table or based on the normal distributions. Okay. Okay. Please conduct the exercise. Fifteen minutes, yeah.
Sir, I already personal chat you, sir.
Hello, everybody. Finish? Any problem? Any problem? Hello?
Say,
Yeah,
can we discuss it together? Say,
discuss. You want to discuss by yourself or discuss with me?
um, with you.
Oh, with me.
But wait, probably the others have done it, but I don't know if no one's done it. Can I
Okay.
discuss it with you?
Okay, no problem. Okay, let's discuss. Anyway, maybe I will make it smaller. Maybe. So okay, can you yeah Satyandika, can you show me your explanations by maybe annotating this screen maybe? Yeah, please. Andika, Satyandika.
Wait, say.
Okay.
Share screen, say.
Yeah, share screen. I actually by not annotating my screen. Is it okay? Yeah.
It says I can't share screen, say.
And
You
you can
disable
share.
the participant share screen.
You want to share screen?
Or annotate aja.
Annotated is okay.
Okay. Wait, ya, say. Sir, I'm gonna running out of space, say.
Out of space. Maybe you can make it more smaller.
My handwriting is really bad, say.
No problem.
I'm gonna try my best. Okay. Alright, so here's the work.
Okay.
It's really messy. First of all, I'm sorry about it.
So the delta x, how much? So the delta x bar is equal to
I'm sorry, what's it?
delta x bar
6
x delta x bar
equals to 6.
6. Okay, good. So the z
Wait,
variable.
I'm sorry about my handwriting, sir. Saya tremor.
Yeah, no problem. And then so
Wait, I think I'm so we found this.
this is 6. So this is a delta, yeah, delta x bar. Is it correct? And for the actually, what is the okay the z
That's the z tanda
yeah,
kurung 0,02.
0,02. How do you compute 0,02?
We find it using the calculator, sir.
Calculated. Oh, okay. So 64. Where is the 64? Where is 64? 64 is 8 tambah
8 itu
2.
pangkat 2 ya.
Ya, ini
Itu 8 pangkat 2.
36, 75, 50. Ya, seems to be correct ya. 0,02 ya. 0,02. Is correct?
Iya. Iya.
Yeah. And how about the z? The value of z?
It's like we reverse use the z table
Yes, that's correct.
and we obtain 2.024.
2.02
24.
24. 24. 24. 24. 24. How do you get this one?
I'm sorry.
How do you how did you get this value?
It's the z
So
0.02.
z point or 2, something like that.
Iya.
Ketemunya 2,024 ya.
Iya. Salah ya itunya atau
Ini benar sih, Z 0,02.
terus dapatnya segitu tapi
2,0. Ini pakai tabel atau pakai kalkulator?
kalkulator sih.
Kalkulator ya.
Mungkin iya.
Pakai kalkulator. Oke,
Harusnya berapa, Sir? Z
20205 ya. Z table. Allow me to check it. Dan 0,02 berapa jadi 2,02 tadi berapa 90. Ini seharusnya 2,05. 2,05.
Oh, sorry about that.
No problem. 2,05. Ya, ya something like that. 2, ini 0, 1, 2, 3. Yeah, something like that. 2,0. Okay. Any problem to find this value?
It's like I don't know how to obtain 2.05 like manually without the calculator. So,
Okay, and yeah.
can I ask how to obtain the Z0.02?
Okay, we can use a calculator. Let me search for the calculator. Normal calculator, distribution calculator. Okay, Sun. So wait a moment. The percent mean is 0 and the standard deviation is equal to 1 and the percentage x is 50. Empat berarti itu 96 berarti 98.
Is everything okay, easy?
Okay. I'm showing the calculator.
All right.
Okay, so now you can see here. Yes, so
I can see it too.
so this above you can see here, but the area should be, you can see here that wait a moment. So the confidential interval is, say I is equal to 96%, right?
Yes.
96% in this area. 96% in this area. Ci is like this. So it is simple to know that this, let's say this is the Z, right? The Z, right? This is the Z lah, yeah. So to find this point is, so usually the calculator will completely compute from minus infinity to this point, or to positive infinity to this point. Okay.
Okay.
And then since we know the confidential interval 96, so we put here is 0.98. Why? Because we include, because we include this area. Okay. So it means that this area is 0.02, right? Also, this one is 0.02. Okay, is it clear? And that's why we put 0.98 or 0.2. Yeah, 0.2 lah. 0.2 is okay. 0.02, something like that, and then calculate. Yeah. So the area is here, 2.054. And okay, please look, maybe look at this my screen and be understand. Oh, be understand.
I hope I understand too.
If no, you not understand yet, and which part that you still don't understand?
Takutnya kedepannya yang ini yang nyari 0,98 gitu-gitu. Oh,
0,9. Ya, ya. Jadi gini. Tadi kan CI-nya 96 ya yang dicari. Iya, yang 96 itu area di sini kan, yang sebentar. Area yang di tengah kan? Area di tengah. Berarti sisa sayap kanan dan sayap kiri kan 0,2 tuh. Oh, I see. Oke. Iya kan, 0,2. Sisanya kan, sisa dari ini kan 0,4. 0,04. Tapi kan karena
ada dua sisi.
Iya, ada dua sisi gitu loh.
Oke sih.
Dua sisi, kemudian kan kalau di tabel, makanya kalau tabel, kalau lihat ini misalkan mana ya, saya kasih tahu, misal tabel nih, tabel Z tabel ya. Nah, misalkan ini deh, gambar ini deh. Nah, oh enggak, ini enggak bagus. Sorry. Image. Maybe it's better. Misal tabel ini deh, kita lihat. Ini kan misalkan untuk nilai Z-nya, ini nilai Z-nya kolom paling kiri dan kolom baris paling atas. Bacanya gimana? Bacanya misalkan 205. Berarti kita cari irisannya di sini nih 9798 equal to 98 kan? Equal to 98. Nah, itu 2,05 itu areanya dari mana? Dari negatif infinity sampai dengan nilai Z ini gitu.
Oh, oke sih. Oke.
Nangkep nggak?
Iya, nangkep.
Oke, kemudian ini kalau pakai tabel. Terus kalau pakai pakai kalkulator, ini kalkulatornya ya. Nah, kalkulator ini mungkin below, mungkin ininya diganti kali ya. Nah, kalau kayak gini kan berarti kan area yang hitam ini kan, area yang hitam. Kalau yang hitam, kalau kita ingin mencari di sini tadi kan berapa? Tadi di sini ini di sini 0,04, yang tengah itu 0,96 ya. Berarti di titik ini kan dari sana ke sini itu kan berarti 0,98 ya.
Yes.
Iya, jadi di sini kita tuliskan 0,98. 0,98. Maka nah ketemunya sama kan 2,05 gitu. Nah, adapun above, below, between, outside ini dicoba-coba aja lah.
Oke sih.
Harusnya sih below berarti menghitung luas area yang below Z berarti kan, below Z berarti di bawah Z gitu loh. Kalau yang above berarti yang menghitung area di atas Z gitu-gitu aja sih. Oke. Oke, so is that clear or not, or still not understand which part?
I clear. I mean, for me it's clear.
Okay, good. How about the others? Is that clear? Yeah, actually we still discuss in the first condition, yeah. We still discussing in the first condition. Maybe the next condition, yeah, next week lah, yeah. Or we want to continue. Okay, anyway, we finish, yeah. Or
Yeah.
Huh? Okay, please exercise by yourself, maybe particularly for these conditions. The first condition lah ya. Okay. Okay, thank you very much for your attentions and see you next week. Oh, next week actually we have a Lebaran ya, maybe 2 weeks later lah ya.
Oh,
2 weeks.
2 weeks from now.
Sorry,
Yeah,
sir.
2 weeks later kan?
Oh yeah.
Next week we have Idul Fitri and yeah.
Idul Fitri.
Yeah, Idul Fitri, and yeah, enjoy yourself and please stay healthy and get together with your family, yeah. And happy holiday to all, ya. Assalamualaikum warahmatullahi wabarakatuh.
So, can I ask?
Oh yeah, you want to ask something? Yeah, please.
Outside topik sih, cuman selagi ada kesempatan saya ucapin mohon maaf lahir dan batin.
Oh ya, sama-sama mohon maaf lahir batin semuanya.
Oh ya, sir, sama saya sudah personal chat ya, sir. Untuk
oh, oke, good.
Oke, makasih, sir.
Thank you, sir.
Thank you, sir.
Selamat Hari Raya, sir.
Assalamualaikum warahmatullahi wabarakatuh, sir.
Waalaikumsalam warahmatullahi wabarakatuh.
Yes.
So, Satya Andika, anything that you want to talk?
No. I just want to say it.
Oh, okay. Yes.
Sorry about that sih. Sorry about that. Tadi nanyanya agak aneh sama handwriting saya.
Oh yeah, no problem. That's good. I mean, you are actually I'm happy if student interested. I mean, motivated by themselves lah, ya.
Yeah.
Okay. See you.
See you soon. Thank you.